Hello, good morning, welcome to my channel. Today we will discuss about moment of inertia second part. We know the moment of inertia about x-axis is equals to area into perpendicular distance y square. Similarly, moment of inertia about y-axis is equals to area of the plane section into perpendicular distance x square, distance square. Here y is the perpendicular distance uh, cg distance, perpendicular cg distance cg distance perpendicular cg distance from x-axis, and x is the perpendicular cg distance from y-axis. Now consider a given axis. Now calculate the moment of inertia about given axis. Moment of inertia about given axis. Given axis, not x-axis, not y-axis. It may be x-axis or y-axis or z-axis. Let us say this is the given axis and this is the given axis, and a thick lamina is split up into small part. Say this is A1, this is A2, and this is A3. Area of the small portion. This is the given axis, and perpendicular distance of first portion, say R1, and second portion of perpendicular CG distance is R2, and the third portion perpendicular distance is R3, and so on. The area of the small portion, like area of the small portion are A1, A2, A3, so on. And perpendicular distance R1, R2 for area 2, and R3 for area 3, and so on. Now moment of inertia about the given axis will be moment of inertia about given axis, say I equals to A1 R1 square plus A2 R2 square plus A3 R3 square plus so on. Now if I sum it, so it will be summation of A into k square. So sorry, yes, exactly, summation of a, or I equals to, we can write a into k square. From here we can find out the value of k equals to, k square equals to I by a. Now what will be the k value of k? K is equals to root over of I by a. This is the k is the radius of gyration. Radius of gyration. This is a very important terms, radius of gyration. It can be asked in exam. The value will be given moment of inertia and area of the plane section, and find out the, calculate the radius of gyration. It may be asked in the examination. Now perpendicular axis theorem. Perpendicular axis theorem. It is most important topic, perpendicular axis theorem. Actually, perpendicular axis theorem, IZZ is equals to IXX plus IYY. Perpendicular axis theorem state that, what is the statement of perpendicular axis theorem? Perpendicular axis theorem state that, I have statement here, I am right. It state that if IXX and IYY be the moment of inertia of a plane section about two mutual perpendicular axes XX and YY in the plane section, then the moment of inertia of the section IZZ about the axis ZZ perpendicular to the plane and passing through the intersection of XS and YY is given by ZZ is equals to IXX plus IYY. Moment of inertia about x-axis, moment of inertia about y-axis. So the IXX and IYY are the moment of inertia moment of inertia about x-axis and y-axis. They are mutually perpendicular. So this is x-axis and this is y-axis. They are mutually perpendicular, and z is the perpendicular to the plane and passing through the intersection of x-axis and y-axis. It is also perpendicular to the x-axis and perpendicular to the y-axis. Let us take a small thick lamina of plane area A, and consider a small portion like dot. This is the small area dA, and it's perpendicular to the x-axis is y-axis, means perpendicular distance y, and perpendicular to the y-axis is x, and intersection, the point passing through the intersection of x-axis is, say, R. Now this is the z-axis. Now moment of inertia about x-axis is of the small portion, small area dA is Ixx is equals to dA of summation of dA of into about x-axis means perpendicular distance y. X-axis, moment of inertia about x-axis means perpendicular distance y into perpendicular distance square. So moment of inertia, actual moment of inertia about y-axis of given lamina portion of area A, if I consider the total area A, then moment of inertia of this lamina will be what? Ixx is equals to area into perpendicular distances square, right? Now similarly moment of inertia about y-axis is equals to summation of dA of small area into perpendicular distance x the square, and moment of inertia Izz is equals to summation of small portion of area dA into perpendicular distance is r square. So it can be written for total lamina of area. If I consider whole lamina of the area A, then A into x square. Now what is R? So like this is the perpendicular to the x-axis, means this is a 90 degree. If I say 90 degree, it is the equilateral triangle. So this is the hypotenuse, and this is the base, and this is the perpendicular. So we can write hypotenuse is equals to r is equals to, we can write r is equals to root over of x square plus y square from Pythagoras theorem. So r square is equals to x square plus y square can be right. So dA into r is x square plus y square. Now multiplying dA into x square plus summation of dA into y square is equals to dA into x square means moment of inertia about y axis Iyy, plus dA into y square means moment of inertia about x axis. That means Izz is equals to Ix, moment of inertia about x-axis, plus moment of inertia about y-axis. This is also called polar moment of inertia. Polar moment of inertia. Now, parallel axis theorem. Complete perpendicular axis theorem. Now next is parallel axis theorem. Parallel axis theorem. Parallel axis theorem. Parallel axis theorem. If I consider a lamina, say this is the CG of the lamina, and let me calculate the moment of inertia about the axis AB, not CG. Find out the moment of inertia about axis AB, IAB is equals to moment of inertia about CG, moment of inertia about CG plus area of the thick lamina of plane A into perpendicular distance from CG, say h into h square. This is the parallel axis theorem. Is the most important equation to find out the moment of inertia of any section. It is symmetrical or unsymmetrical section. We can find out the moment of inertia by the using this equation, this formula. It is most helpful formula to find out the moment of inertia. Thank you.